Okay, there's an important principle to understand here with standard form. Let's say, for example, you've got something like 3 times 10 to the power 7. If we multiply 3 by 10 to get 30, so if we've multiplied this number by 10, we have to divide this number by 10. So it becomes 10 to the power 6. If, for example, you've got 3 times 10 to the 7, and we decide that we want to divide this one by 10 to make it 0.3, this is divided by 10. This has to be multiplied by 10, and 10 to the power 7 multiplied by 10 is 10 to the power 8. It's just playing about really with standard form numbers. Now, let's say here we've got 3 numbers, x, y, and z. Each of them is between 1 and 10. So each of these numbers is in standard form. The only trouble is at the moment is we've got to write z in terms of x and y. If we had something like this, let's say we've got this, 3 times 10 to the 6 plus 5 times 10 to the 6 is equal to, let's say we've got p times 10 to the 6. If all the numbers were times 10 to the 6, in other words, well this, if you've got 3 times 10 to the 6 plus 5 times 10 to the 6, actually that's 8 times 10 to the 6. And if that is equal to p times 10 to the 6, then 8 is equal to p. You get the idea. So at the moment, x is times 10 to the power 5, z is times 10 to the 5. The problem is this y. Now, if you've got y times 10 to the power 4, and you want to rewrite that as something times 10 to the power 5, which is what we want to do, this side we have multiplied by 10. And because we've multiplied that by 10, to compensate, I've got to divide this by 10. In other words, y times 10 to the power 4 is the same as y over 10 times 10 to the power 5. So now we've got that x times 10 to the power 5 plus y over 10 times 10 to the power 5 is equal to z times 10 to the power 5. And as in common with this over here, 3 times 10 to the 6 plus 5 times 10 to the 6 is 8 times 10 to the power 6. I can rewrite the left-hand side here as x plus y over 10 times 10 to the power 5, and that is equal to z times 10 to the power 5. And now, just by comparison, I can see that z must equal x plus y over 10. So z is equal to x plus y over 10. Bit fiddly, that one. Right, we're now told that we've got 3 numbers, 3 times 10 to the n, 4 times 10 to the m, and 8 times 10 to the p, and they are all in standard form. And we're told that 3 times 10 to the n over 4 times 10 to the m is equal to a times 10 to the p. So I'm going to play about with the left-hand side there. 3 times 10 to the n divided by 4 times 10 to the m. I can split that into 3 over 4 times 10 to the n divided by 10 to the m. And that's just the same as, well, 3/4 is 0.75. And by the laws of indices, I know that 10 to the power n divided by 10 to the power m, we can subtract the powers and make it 10 to the power n minus m. And that is equal to a times 10 to the power p, because we're told that. The only problem is that this a times 10 to the p is in standard form, which means that a has got to be a number between 1 and 10. So what I'm going to do is I'm going to take that 0.75 times 10 to the power n minus m, and I'm going to adjust it so that it is in standard form. And for it to be in standard form, that 0.75, I'm going to have to make it into 7.5, because for standard form, this number must be somewhere between 1 and 10. Now I've multiplied that side by 10, so to compensate, I've got to divide this side by 10. And what I should have realized is if I've got something like 10 to the power 5, if I divide that by 10, it becomes 10 to the power 4. So in other words, you subtract 1 from the power. So this 10 to the power n minus m, to make the power to divide by 10, I'm going to have to subtract 1 from the power. So I've now got the fact that a times 10 to the power p, which is in standard form, is equal to 7.5 times 10 to the power n minus m minus 1. So by comparison, a must be 7.5. And the last bit says, find an expression for p in terms of n and m. Well, if I just compare these, p must be just n minus m minus 1.